Chapter 3, Section 3, Question 1. You might say, I recognize that problem. We did a problem just like it back in Chapter 2 when we were solving for y. And we did. But now it's different because it says, write the equation in standard form. But what is standard form? This is standard form. ax plus by equals c, something with an x, something with a y, equals something with something else. No fractions or decimals, and this first coefficient has to be positive. So, no fractions or decimals. I need to get rid of my fractions, but we learned how to do that back in chapters 1 and 2. So here, we have a common denominator of 3, so I need a 3 on the bottom and a 3 on the top. I need a 3 on the bottom and a 3 on the top. That doesn't say 35, I need to have parentheses there. Equal sign, common denominator on all the terms. This doesn't need to have 3's on these because this vinculum, it's all being multiplied, so this is all one big term here. So, equal sign, common denominator, they act like laser beams, and pew pew, they're gone, and we get 3y minus 15 equals 4 times x minus 2. If you get rid of the fractions correctly, I'll let you have half credit to get this far. But we're not done. We need to get standard form. Distributive property from chapter 1 to the rescue. We have 4x minus 8. We need to get x's, y's equals number. The x's, here is where it actually matters which side you're going to write your x on. I need to have the x term on the left-hand side. Notice that I didn't put it under either of these because I want it to be combining like terms. I want my x's first, my y's second, and I want this number on the far side. Oh, rats, that was a plus. There we go. Sorry, that was a plus 5. Maybe I shouldn't have written it there. How about that? Okay, cool. Gotta be able to read what I'm writing. All right, and then we have negative 4x plus 3y. Keeping that equal sign lovely lined up, minus 23. Now, no fractions, no decimals. A is positive, A is not positive, A is negative. There are 3 ways to change this. 1, you can multiply everything by -1, you can divide everything by -1, or you can change every sign. I will take either of those. Now, for the people who are going to divide by -1, be careful. I have seen students do this. They're just dividing by a negative. You can't just divide by a symbol. You have to have -1, -1, and -1. That will work. And then you will have 4x minus 3y equals 23. That is your answer. In standard form, a lot of students are going to find this in slope-intercept form, and they will lose half credit. Chapter 3, Section 3, Question 2. We have learned about standard equations. Standard form equations are these: x's, y's equals number. They're very useful. They're going to be used to find the x-intercept and the y-intercept. To find the x-intercept, if you think about it, an x-intercept is on the x-axis, therefore the y has to equal 0. So, first, you're going to make y equal to 0. So if I take this and make y equal to 0, x is equal to 3/2, and we can write that as an ordered pair. Now, 3/2 might be confusing to graph, so you might want to make that into 1.5, which is the equivalent decimal. And then y would equal 0. For the y-intercept, something on the y-axis, x would have to equal 0. So x is equal to 0. We're going to take the same equation and make x equal to 0. And write that as an ordered pair. X first, y second. That right there gives me 2 points, and 2 points determine a line. So we can have x is 1.5 comma 0. I have to eyeball where that is, and 0, -2. Now, these are fairly close together, so if I were to make a line, I might not get all the points correct. So I'm going to do my best on this and draw in something that goes through here and through here. Hold this in place. And I'm going to draw a line, and frankly, I'm fairly certain that this line is going to be wrong when we check it. So here's my x-intercept. You are welcome to abbreviate that x-int instead of x-intercept and y-int instead of y-intercept, if that will help you out as you are writing. Now, the slope-intercept form is nifty. We solved this for slope-intercept form back in chapter 2. We subtract the x's over. And we want our x's first and our plain old numbers second because we want descending order by degree. Divide everything by -3. And reduce, reduce, and reduce. Now, this is slope-intercept form. The first thing we're going to do is we're going to make a dot at y equals -2. We have a dot at y equals -2. Second, we're going to follow our slope, which is 4 over 3. Slope is rise over run. And so a +4, like a little hot air balloon, positive goes up, negative comes down. And the little dude running, and he's going to run from left to right like we read here in the US. And so for him, going to the right is positive, going to the left is negative. If you are ever confused about this, take a look at a graph. Up is positive, down is negative. Right is positive, left is negative. That's how our Cartesian coordinate plane was made. So +4 goes up 4, and a +3 goes right 3. What's the opposite of up 4? That would be down 4. What's the opposite of right 3? That would be left 3. So from here, our starting point of -2, I'm going to count up 1, 2, 3, 4, right 1, 2, 3, and make a dot. I missed that by just a tiny bit. I'm going to do it again. 1, 2, 3, 4, 1, 2, 3. I missed it by about half of the box. This is why, while this is a very nice way to get a feel for where your graph should be, it's not going to give you a very exact line, especially if you don't make the rest of these points. So, why did I do this side? Down 4, left 3. That's because there's more room here. I'm going to go down 4, left 3, and make a dot. That way I have all the points there, and I can make a very, very nice line. Whee! Keeping that very nice and stable, keeping my pen right up against the edge of that ruler so I can have the line. And it does go through those points, and it goes through all the other points that make up the line in slope-intercept form. The other reason to do it this way is that if this number here is ever a 0, you'll only get a single point. That's not enough to make a line. This way will work anytime you have a line. Chapter 3, Section 3, Question 3. Finding intercepts again. This is our function notation again. F of x is also known as y, so I can rewrite this as y equals -3/2 x. Now, we need slope-intercept form to graph this, and slope-intercept form has y equals mx plus b, so what is added out here? Our additive identity from back in chapter 1 says we can add 0 and it doesn't change anything. So therefore, we can have step 1, we're going to make a dot at y equals 0. Step 2, now this negative is often written in line with the vinculum. It also means that a lot of students accidentally don't see it because they don't see this break here. So be careful about that. Usually we put it on top or bottom, but not both. I'm going to put it on top. That is much more common. Remember, rise over run. So a -3 would take it down 3. And a +2 would go to the right 2. The opposite of down 3, right 2 is up 3, left 2. That's how we're going to graph it. We're going to go a dot at y = 0. And we're going to go down 3, right 2. Down 3, right 2. And we can't go any further. We go back to the beginning. Up 3, left 2. Up 3, left 2. We're counting it up. We're making a nice straight edge line. In my class, you will use a straight edge. Or you might lose points for not using a straight edge. Because right now, we're drawing a line. But the thing is, later on, we're going to have 2 lines on the same graph, and we'll need to know where they cross. We're going to have 3 or 4 or 6 lines on the same graph, and we'll need to know where all of them cross each other. And if you are not making really nice lines, you will not be able to handle math later on, like next chapter. All right, so here we go. We have our lovely straight line, our x-intercept. It hits the x-axis at 0, but you can't just say 0. Intercepts are going to be written as ordered pairs. The y-intercept, it hits the y at 0. This is one of those cases where it comes out as only 1 point if you were to do it using the standard form. By the way, I'd like to show you a quick art project. This is what I see when I see the ordered pair 0, 0. I see a little owl. All right, write it in slope-intercept form. This is slope-intercept form. Slope-intercept form is really wonderful for making all of the points that come out nicely. I don't really need the other ones because you'll have to estimate on those. Chapter 3, Section 3, Question 4. Boring lines. Now, boring lines are because it tells you, for our t-table, that y is -3. Y is -3 when x is -4. Y is -3 when x is 0. Y is -3 all the time when x is 2. So if I were to make -4, -3, 0, -3, and 2, -3, take a look, they line up beautifully to make a horizontal line, all of which have a y equal to -3. Slightly past the edges, arrows at both ends. That is why it's called the line y = -3. Aha, but wait, there's more. There's x = 4. That means that x is always going to equal 4. X is always going to equal 4. X is always going to equal 4, even if y was -6, even if y was 1, even if y was 5. All right, so 4, -6, 4, 1, and 4, 5. We are going to have all these points and more along the line. X is equal to +4. Slightly past the edges, arrows at both ends. So this is the line y = -3. Since I have 2 on the same graph, I'm going to label this one as y = -3 and this one as x = 4. Chapter 3, Section 3, Question 5, using the graphing calculator. We're going to use a graphing calculator to show you how to enter in this function notation equation, graph it, and then use the functions in the calculator to find the x-intercept and the y-intercept. But in case you don't have your graphing calculator, we can actually do this by hand. So f of x is also known as y equals -2/5. Notice how I move that negative up so I don't forget it, -1/5. If you remember, the x-intercept means that you're going to plug in that y = 0. And the y-intercept, you're going to plug in x = 0. So y is equal to 0. I'm going to plug in a 0 there. I'm going to move my 2/5 over to the left-hand side because there are teachers who would like the x on the left-hand side. Notice that I move the negative to the top. I have an equal sign with common denominators. I can immediately, pew pew, move that out of there and keep solving. Dividing by 2, and I get x equals negative 1/2. But wait, if I'm going to write this as a x-intercept, I can't just have x equals negative 1/2. Our x-intercepts are going to have to be written as ordered pairs. But wait, there's more. I'm going to take this same equation, y equals negative 2/5, x minus 1/5. And I'm going to plug in that x is equal to 0. Y equals negative 2/5. Plugging in that x is equal to 0. That gives me y equals negative 1/5. Oh, that's nice. Why did that happen? That's because y equals mx plus b is slope-intercept form, and the intercept that this represents is the y-intercept. Do be careful. Some people will put negative 1/5 comma 0, but that is a y value, so we need 0 comma negative 1/5. Hey, those are the answers. The same answers we'll get in the calculator. The reason I'm showing you how to do it in the calculator is because right now they're still going to be able to be solved by hand. But in 121, you won't be able to. You'll have to use the calculator. So you might as well start now.